Hello, this is just a quick video for those that wanted to know more about the cross cancellation. I didn't know the name, so here goes the name. Cross cancellation method when you are multiplying and dividing. So this is more so if you are struggling with being able to reduce or being able to identify whether to turn it into a mixed number, whether to reduce it. This helps make the numbers a little bit smaller instead of reducing at the end or turn it into a mixed number at the end. You do all that at the beginning. So really quickly, I'm gonna just make up a couple of problems. Again, if you like it and you know how to use it or want to practice with it, continue to practice with it and get better with it, because again, this is very useful and it will help you on further down the line. But if this way is confusing for you, please do not watch this video. Exit out so you will not get confused. But here we go. For those that's always up for a good challenge, let's go ahead and let's just look at a few of them. And again, I'm just making some up. So let's say if I have, so let's say if I have the following problem. We're going to look exactly what it's telling you to do. We're going to look across and see if these numbers have something in common. So if I look across, I have 9 and 3. Do 9 and 3 have something in common? Yes, they have 3 in common. So if I divide 3 by 3, my new number would be 1. If I go 9 divided by 3, then my new number would be 3. And let's do the same thing with my 5 and my 10. What's the number that both goes into 5 and 10? 5. So I would do the exact same thing. 5 divided by 5, I get 1. 10 divided by 5, I get 2. So now, if this is a little bit confusing, let me rewrite it. So now I have 1 over 3 times 1 over 2. Do you see how it made that those fractions so much smaller than what they were? And then I'm going to just multiply straight across. 1 times 6. Let's look at a couple more. Okay, so let's look at this second question. And we're going to do the exact same process. So we're just going to look across from one another and see if it's numbers that goes into both of these numbers. Let's do 5 and 15 at first. Is there a number that goes into 5 and 15? And again, it has to be that same number. Yes, 5. 5 goes into 5. 5 goes into 15. 5 goes into 5. One time. 5 goes into 15 3 times. Let's look at my next one. What's a number that goes into both 12 and 3? 3. Divide by 3, that gives me 1. Divide by 3, that gives me 4. So now my new number let's look at 1 or 2 more and then try some on your own. Okay, so let's look at this division problem and see if we can practice or do the same thing. Again, this is a problem I just made up. So let's see if it'll work by doing the same process. So the first things first, I have to convert this into a mixed number. So that's first. Into an improper. Times, add. 1 times 2, that's 2, plus 1, that's 3 over 2. Remember when we divide fractions, we would do keep, change, reciprocal, or keep, change, flip. Keep my first fraction, change, and then I'm going to divide. So in this case, reciprocal, 10 over 9. In this case, I'm going to look and see what my cross products have in common, or my cross cancellation have in common. 3 goes into 3 one time. 3 goes into 9 3 times. Let me choose another color. 2 goes into 2 one time. 2 goes into 10 5 times. Now, let's rewrite my fractions now. So now I have 1 over 1 times 5 over 3. And again, I just multiply straight across. I get 5 over 3. 5 goes in the inside, 3. I get 1 and 2 over 3. Let's try one more division problem, and let me know if you like this. Okay, so let's look at this problem. We're going to do the exact same process. This time I have 2 mixed numbers, so I have to convert both of those into n proper. So I do that by times and add, times and add. 2 times 4, that's 8, plus 1, that gives me 9 over 4. Keep, change, reciprocal. 1 times 3, that's 3, plus 1, that's 4. So I get 4 over 3, but then I have to do the reciprocal of that number. So in that case, that gives me 3 over 4. In this case, can we do my cross product? No, we cannot do a cross product because there's nothing that they have in common. 9 and 4, and 4 and 3. So in this case, we could not do cross product on this one. Okay, so let's look at this last problem, just to see again if we can do cross product on this one. So first, again, you would have to do my Texas or turn it into an improper. So let me put that back, sorry. So times it by plus. So 2 times 3, that gives me 6, plus 2, that gives me 8. 8 over 3. Keep, change, reciprocal. And again, that's just a big word for flip. So now I would go in and see whether my 2 diagonals or my 2 cross have something in common. What does 8 and 2 have in common? They have 2 in common. So I know I can divide each one by 2. Divided by 2, that gives me 1. Divided by 2, that gives me 4. I'm going to do the same thing with this diagonal. What's the number that 3 and 3 have in common? 3. I'm going to divide it by 3. That gives me 1. Divided by 3, that gives me 1. And so let me rewrite my new fractions so that will help you. So now I have 4 over 1 times 1 over 1. 4 over 1, which is the same thing as 4. Good job. Let me know if you like this method.